research publications, research project leader, blah, blah, blah. And probably what I'm most proud of is a web tool that we've worked on for a number of years that provides forest carbon estimates in the US at any scale. They match the national estimates, they go to the Framework Convention, and the users on the web tool can go to the websites and pick and choose different areas of the US and make regions fairly small to come up with these carbon estimates, and they're consistent from the national level all the way down to a smaller landscape level. But I put all that aside a couple of years ago and became a secondee to the Global Environment Facility, and I recently returned from the GEF. At the GEF, I was the program manager for the land use change and forestry objective and the climate and chemicals team. The amount of funding on that's about $50 million in US terms. I also worked across to the Sustainable Forest Management Red Plus Challenge Incentive on a team that included a member from the biodiversity group and land degradation. The challenge incentive is about $250 million. So my talk today is based on my experiences over the last 20 years on forest carbon estimation and the last 2 years working at the Global Environment Facility. Well, I'd like to say that I'm reducing my greenhouse gas footprint by not attending this meeting, but instead I'm going to be on a plane, well, I'm on a plane right now, flying from the US to Kenya to attend a workshop on carbon tools, and you'll hear a little bit about those in my talk today. So I'm not sure that I'm really reducing anything. The real issue is I hope to be available to answer your questions via email or phone later today, and instead I'm going to be on a plane. So I want to encourage you, please, if you have any questions or comments, please email me. That information is in my presentation, and Shaylee will be making sure that you have that information also. Thank you for your attention, and I look forward to hopefully meeting you sometime in the future. Have a great meeting.
It's an 11-hour time difference from where we're from, but Linda was going to get up basically in the middle of the night to answer questions, and she's really disappointed that she won't be able to do that. Her presentation is not included on your flash drive because it has audio, and so after you've seen it, she sent me, after I arrived here, a smaller version of it that wasn't such a large file size. So if anyone would like that, because there are a lot of sort of World Bank contact pieces of information in there, I have that, and we can, if you have your computer with you, we can do that at a break, or you can just write me a note and I will email it to you. Okay, now for the really exciting stuff. Forest carbon basics. So we do have some people, this is not going to be new to you. I invite you to, there will be a contest later because I do have other door prizes. So if this is not new to you, I invite you to compose a forest carbon related haiku, 5 syllables, 7 syllables, 5 syllables, and we'll read them out at the break and pick the winner. So that's for a handful. So it seems really obvious. This seems like a silly question, right? What is a forest? And Linda's been involved in a lot of these international negotiations, and this is one of the things that is up for a lot of discussion. And you think, well, that's silly, everyone knows what a forest is. Well, it depends on where you're from. Because in the United States, we might have land that we call woodland. We don't even classify it as a forest because the canopy cover is insufficient. And yet, in another country, that might be a fairly robust forest because it depends on climate and a lot of other things. So this is sort of a generic definition of forest, and you can see the percentages aren't filled in, but usually a country will define forest, and it's based on stocking level, the amount of land occupied by trees, and then there's often some component of crown closure as well. So one of the first things to remember is that forest is definitely in the eye of the beholder. The other thing I should mention is that in the IPCC guidance, when you report, you have these different categories. We are talking specifically today about forest remaining forest. If there's land use change, then some of the changes in these pools are going to be quite a bit different. So we're talking about forest remaining forest. But if you are engaged in an afforestation or reforestation project, your basic methods won't change. I mean, until a tree has a breast height and has a diameter at breast height, you really can't measure it. There's not that much carbon in very young trees in the beginning part of a project. But overall, the approach doesn't change. There are just other considerations if you are in an afforestation or reforestation situation. So I just wanted to be sure that I was upfront about that. So everybody probably knows this. Does anyone know why that one greenhouse gas is in a different color? No? No? Okay, that one is a chemical made by humans. So all of the other ones naturally occur, we may also cause them to occur. And they interact with forests in different ways. But sulfur hexafluoride is, I believe it's a refrigerant, but that one is a very potent warming gas, but that doesn't interact with forests in the carbon cycle, and it does not occur normally in nature. So everyone's probably seen this slide. This is the famous Mauna Loa Tower data in Hawaii. And this shows from when the tower went operational in 1960 until the present. And I'd like to show this one, not so much for the increase in CO2, although that is alarming, but those oscillations. And I'm going to zoom in from 2008 onwards so you can really see those right there. And my question I asked to a bunch of high school kids the other day, and they knew the answer. Do we know what causes those wiggles? Somebody does. Anybody? What are those oscillations from?
Seasonality.
Sorry?
Seasonality?
Yes, leaves on and leaves off in the forest. So today's door prize is a DVD of a forest and grassland short course for actually U.S. forest managers, but that's your prize. See, I told you I had door prizes. So the reason I like to show this is because sometimes what you hear, we hear all these numbers, and I know the number parts per million I learned in graduate school was 370. And I always have to look up the current number, and I'm always sort of horrified. So it's easy to think, oh, we have all these emissions. What can forests really do? Well, this is a slide I use to remind us that really forests play an important role in the global carbon cycle. They really do. And when you start to doubt that, you start to doubt the power of forests in mitigation, remember those squiggles, to use a technical term. So, this is basic for a lot of us, but I did one talk one time and I found out the whole time somebody was wondering how the carbon got into the tree. That was my fault, so we start with photosynthesis. Take carbon dioxide to fix the sun's energy. Plant tissues, about 50% by dry weight. It does vary a little bit. Carbon, so this carbon is temporarily removed from circulation in the atmosphere. So forests may serve as carbon sinks. Oh, this is time for another prize. I have a poll. Are forests carbon sinks? So you have 4 possible answers here. And I think we'll do this by standing up. So if you think the answer is A, your choices are always, sometimes, usually not, or it depends. If you think the answer is A, please stand up. Ooh, good job. B, sometimes?
What's the difference between B and E?
Good question. There isn't really one. C, usually not. And D, it depends. So I circled it depends, but that's really also sometimes. So who was the first person to stand up on sometimes? I think it was you. I think it was you.
Yeah.
I'm not going home with this. Worse yet, there's a horrifying video of me on it talking about So that's right. It really does depend. Sometimes they are, some forests, U.S. forests are on the whole, across the United States, a net carbon sink, but any individual forest can be in different places. So trees, we know they take up carbon dioxide and they store it as wood and other tissues. Carbon's also stored in the soil. How does it get there? You've got decomposing roots, decomposing leaves, that sort of thing. Soils, I think this is really cool. Soils actually can absorb methane, which is a more potent warming gas. And in some situations, we actually, that will happen, and it can be a fairly strong sink, depending. And then sometimes we forget about, but wood products, carbon in wood products is also stored. And I always like to, I should take a picture of it. I have an antique cherry table that I bought. And it was made, they estimate, somewhere between 1850 and 1880. And I'm not letting that table go anywhere. So obviously that carbon's been sequestered for quite some time, and it's planned to keep it that way. Yes?
If you don't mind, could you briefly explain how soils absorb methane?
It has to do with the microbial community in the soil. So forests also release carbon. This is the other side of the equation. Just like we respire, everything in the forest, the trees, the soil, fungi, the bacteria, they all respire as well. Decomposing dead wood debris, all of that. Normal part of the forest life cycle. Forests can also emit from the soil, again, function of the microbial community, nitrous oxide. Generally not so common in a drier upland soil. In wetter soils, it definitely can be a component, an interaction with greenhouse gases. And again, if we have land use change, then this equation will be a lot different. We're talking about forest remaining forest. But when you have land use change, then this is a different picture. So this equation, we always talk about where we are, what side of the line we're on. It depends on a lot of things, actually. So any given forest can be a carbon source, a carbon sink, and it can bounce back and forth across that line several times over the course of the season or year. Age class distribution plays a role, forest health and disturbance history. A lot of Canada's boreal forests, we all know they've had terrible epidemics of bark beetles, and they have large amounts of mortality. So those forests are sources generally right now. Management practices can change that, obviously, and weather conditions. In areas where they have continuous monitoring, they often find, if you have drought and things get dry, a forest will, the sink strength will drop. It may become a source, or it may be not doing too much of anything in a net sense. So this can change on shorter and longer time scales. Right now, net U.S. forest offset, the last reporting year, I believe Linda told me it was about 10% of total U.S. greenhouse gas emissions were offset by forest growth in the United States. So we are still a net sink. Although you see the news and you see the forest fires, obviously those areas are sources. So it's not a simple answer. All right, I've included a free sort of travelogue because I like to do that. The first picture was taken out west of the Wind River Experimental Forest, and that was taken from the crane. So I took that actually from above the forest canopy. This was taken from the summit of the impressively named Mount Hedgehog in New Hampshire, just to give you a little taste of my favorite season, fall. So we're going to go over the pools, and again, these are as defined by IPCC. Just a little picture there, we've got our major pools. Below ground biomass, live dead, above ground biomass, live trees, and understory. IPCC considers it. We'll do a little more detail on these. Standing dead, down dead wood, and then of course the soil. So these are the current IPCC definitions, and they break them into three main categories. So that's that leftmost box. Now, the dead organic matter, dead wood, and they call it litter, and this is exactly what you think it would be. It can actually be buried too. So dead wood is not, by their definition, just what you see lying there. It may also be buried. It includes stumps too. We sometimes forget about stumps. Large dead roots. Above ground biomass is exactly what you think it is. It does include understory, something we tend to often ignore. Soils, they use the term soil organic matter, and that always sort of bothers me a little bit because soil organic matter does have carbon in it, but it's not the exact same thing as soil carbon. But these are the pools that you have to report on for country level reporting.
Yes, for the dead wood, how do you account for these changes due to tidal inflation?
I'm sorry.
In a mangrove ecosystem, changes due to tidal inflation, the dead wood component.
You know, I am not certain because I haven't worked in mangroves, but I do know there's a report, and I want to say it's on the FAO website, but the author's name is Boone Kaufman. He was with the Forest Service, and carbon in mangroves is his specialty, and I believe he has a whole report on carbon in mangroves that, because that's what he estimates, it probably covers those details. So if you want me to write that name down for you later, I can.
I got this call.
Okay. So we'll go into a little bit more detail on each of these. And live trees, obviously, this is the easiest thing. This is what most people are inclined to measure. If you're managing for timber at all, this is something you really care about. You may already have data for this. We're very fortunate in the United States. We have something called Forest Inventory and Analysis. It's the nation's forest census. And it is a grid across the entire country, partial coverage in interior Alaska because that's challenging terrain. So we're very lucky to have these data. A lot of other nations are ramping up their inventory program. Canada has one, Mexico's building one. The European Union used to inventory and then they didn't for a while. It's quite expensive and they're ramping up their programs as well. And now as part of Red Readiness, many other nations are starting to build inventory data. So you might be lucky and you might already have some. Although as we'll talk about later, it might not be the spatial scale suitable for use in the project level. So you often will have to take inventory data anyway. Remote sensing can provide data. Again, this may be sort of a rough estimate. It may not be appropriate for your particular use, but it's often sort of a good ballpark to get you started. And again, it depends on the scale at which you're working, whether you're doing country level reporting or you're trying to do a project. Standardized methods for data collection, generally not technically difficult for live treaties. Some issues in the tropics that you have to address, but there are standard protocols for dealing with most of this. We'll talk a little bit about LiDAR later. The thing with inventory is it's not technically difficult, but it's really time consuming. It takes a lot of person hours, and I know someone had mentioned that was the thing they couldn't afford inventory. And you'll hear this, you'll see this in the Guyana presentation. One of the things you can do, designing an inventory that meets error specifications for something like RED takes some technical know-how. And that's something that you could hire a consultant to do. But putting a tape around a tree is really the kind of capacity building that should happen at the local level. I see, and there have been demonstration projects, I see no reason why community members should not be involved in collecting that field data. And that will reduce your measurement costs considerably. You can be trained to do it quite easily. It brings ownership of the project to everyone. And I think it's the most efficient way to go about it is to take a community forestry approach to measurement and inventory. So it is a hurdle, but I think by having a train-the-trainer model, you can go ahead and make that work on the ground, and that will really remove one of the barriers to data collection. Paying professional crews is extremely expensive, but you don't have to have professional crews to measure every plot. Did you have a slide?
Oh, sorry.
Okay. So that's sort of what if I had an actual soapbox there, I stood on it and I'll get off the soapbox now. But I think sometimes everybody thinks we have to haul in all these expensive crews, and you do need to have your design. You should have your design done by an expert in that to make sure it meets the targets. But to implement inventory, I don't believe that requires expensive professional crews. Below ground biomass, this is lots of fun. These are usually estimated with root to shoot ratios and some other types of equations. This is very hard to do. Methods I've seen used involve fire trucks. If you buy firemen a lot of beer, they will bring the truck out into the woods and take the fire hose and the tank truck and blast all the soil away from the roots, and then you can excavate them. I've seen people use backhoes and other things. It makes a huge mess. Your sample size is pretty limited because it's incredibly destructive. So usually we rely on some other people who've made a big mess, and then we use these published ratios to estimate it. Honestly, 20% of above ground biomass is not a bad rule of thumb. It does vary with the diameter of the tree, but 20% it's not, when I've checked it out, not a bad ballpark. So you generally are not going to have those data available anywhere unless there's been some sort of site-specific research study. Fine roots, the really tiny ones, we capture them into the soil pool. It's really not at all practical to try to pull that out. Dead wood and litter. This again is a big grab bag. It includes a lot of different things, including stumps. It's easy to forget about stumps, but depending on stumps,